So, so what you need to do is it's basically an LRU cache. You need to implement using a data structure, and there are basically two methods that you have to implement: get and put. Get being if the key of the element is present, then you get me the value for it, and put is if the key is not present, you insert the record, and if it is already present, then you have to basically eject it and then put it back again so that it becomes the most recently used one.
Mm-hmm.
Okay.
Okay, so.
And I'll give you a few examples. For example, I had the problem in Java, but I'm basically a Java coder.
Yeah, sure.
Who writes code in some other languages too, like C or C++. So that's fine. So essentially what you need to do is, so let's say if you have a cache, you put the first element 1, 2. For the simplicity of this question, let's just take in that the key and values are the same. So if you say put in a key of 1, the value output should be 1. If the key is 2, value of that is 2. So it's just a numeric values and keys. Okay. And at this point, at this juncture, if you have inserted 1 and 2, if you retrieve the most recent one, you will get 1 over here in this line. And then you go ahead and put 3. And then next time when you get the output, get 2, it should return you 2, and then make that as the most recently used. Okay. So is the problem clear?
Yes, it is.
Okay, great. Yeah, go ahead with however you want to start off with, and I'll also tell you that if we get across this problem faster, then we'll spend more time on another problem.
Okay, great.
Yeah.
So just to clarify, if the element is not in the cache, then we when we try to get that element, then we should just return none.
Yeah, return none, return -1, whatever feels good. I made it -1 just because we only deal with integers.
Okay, I see.
But,
okay.
Yeah.
So I think the general approach is so you can have a hash table that
Okay.
That points to a node, which is part of the linked list.
Okay.
And so that's what happens when we do object.put11.
Okay.
And so node 1 is a linked list, and you try to put in 2. First, you check that the hash table is smaller than the max capacity. And I guess you put it behind this node 2, behind the node 1. I think it'd be better if we put it before node 1.
My quick question over here, pardon my understanding of if this is very specific to Python, but why are you using hash table with the value being a linked list node?
So I think this would just store a reference to this pointer, or it'd be a pointer to this node, or this one rather.
Let's say we are just dealing with integers. I mean, very basic. There are no objects much, and we don't need to take care of the pointers or anything. If it's a very simple numeric value.
Okay.
I mean, yeah.
Yeah, that makes sense. So let's start from the beginning. So if we have one, then we append, we add the one to the cache, and then we put two, but we're gonna have to somehow keep track of which one was least recently used. So
what is the data structure in Python that does this?
A dictionary.
Yeah.
So one is the key and this one is the value.
Sure.
I think we do need a linked list to sort of, I'm thinking that we need a linked list to keep track of the order of how these were added to our dictionary. Because, so first it's one, that's the most recent. And then when we add,
dictionary maintain the order of insertion?
Oh, yes, dictionary does.
So if it does maintain the order of insertion, then do you need any other data structure to keep a track of the order?
Actually, I don't think that the Python dictionary keeps track of order.
Probably maybe in the, yeah, that's a bit strange with Python is that they have, I don't know what version of Python is running right now, but I can Google it up, but I think the latest one does it, Python 2 point something or 3, Python 3 maybe.
Let me just quickly try it then.
Sure. Go ahead.
Okay, we have a dictionary.
Yeah, and if you need to Google up something, I'm okay with it.
Okay.
Yeah, and usually in the interviews also people are usually okay. I mean, you can ask them.
Okay. Yeah, it doesn't seem to store the order. Because it should have printed B and A first, but it printed A and B.
Can you try adding some more so that I'm just saying if it maintains the reverse order? I mean, either way, if Python key does something.
I think it sorts it by like alphabetically. Oh, interesting. So why is this?
A, C, B. Okay, so there is no order. Okay.
Okay, there.
A, B, C. Yeah, there is no order. Just maintained. That's fine. Quickly, can I switch you to Python 3 and let's try this?
Sure.
I think I just googled it up. So, can you try running this one more time? Are you still there?
Oh, yes. Can you see what I'm doing?
Actually, no.
Oh,
Oh,
oops.
sorry. What screen?
Sorry. Can you see me? Just uncomment this.
Yeah, yeah, you commented that out. Yeah.
Okay, cool.
Okay. Yeah, let's try this.
Okay, great.
VAI.
So there seems to be
Yeah.
order. Okay, awesome.
Yeah.
Then if the dictionary maintains order, then I think we can simply put 1 and then put 2. Which means okay. So if the 2 is added after the 1, okay, and then when we get 1, we just simply remove it and then add it again. So
Yes.
that was line 13, and then for line 14, we add it to the end. And then we try to get 2. And then we put 4. Oh, oops.
Yeah, that's right.
Right, so it was at 1, 2, and then we got 1, right?
Yeah.
And then now we want to put 3, so we simply
Yeah.
delete the first entry and then add 3, 3. And then
Yeah, if the capacity is 2, yes. Okay.
right.
Yeah.
And then we try to get 2, but it doesn't exist, so we can simply
Right.
give them -1. And then we put 4. 1 is the least recently used. And then we get 1, which is also -1.
Right.
So I think that's the general approach.
Right.
Is it okay if I begin to implement that?
Yes, please. Go ahead with the implementation.
Okay. This should be a class, LRU Cache. So this has a initializer and a put. And a get. So this is going to need a cache, which is just going to be a dictionary. Maybe this can have a given max capacity. Now, when you put the value, you want to do the length of self.cache is less than the self.max capacity, and you're just free to append the key value to our cache. So you do self.cache at key value. Otherwise, you need to remove the first entry from our cache. So need to delete. Well, let's figure out what the first key is first. Keys at 0. Once you figure out the first cache, you can do delete self.cache at first key. And after deleting that first entry, you're free to add to that dictionary the key value. So if there's a successful put, should we just return true? Does it matter what we return after the put?
No, it doesn't matter what you return after the put.
Okay, we'll just return
let's just put be void or whatever.
Okay. So for the get, you can simply do value is in self.cache, and you want to to get the result. We want to get what that value actually is. I think this should be more appropriately named, which is key.
Mm-hmm.
So we're going to return that result at the end, but before we do that, we have to delete self.cache at the key, and then add it again. Return result. The key is not in self.cache, and return -1. So just to make sure that we're doing this correctly, just run through the example input again.
Okay.
So we create a new LRU cache with max capacity of 2, and when we put in 1, 1, length of self.cache is 0, and 0 is definitely less than 2, so we can add in the 1, 1. We can also do that for 2, 2.
Mm-hmm.
So at that point, we're going to have something. The self.cache is going to be 1, 1 and 2, 2. And we try to get 1. 1 is in the self.cache, so we get the value, delete that, and then add it again. And then we just return 1.
Right.
And then we put 3. So we're at max capacity. So we get the first key, remove it, and then add 3, 3.
Mm-hmm.
And then we try to get a non-existent 2. So we just simply return -1. And then we put 4. And we return -1 when we try to get 1. So I think this should work.
Is there a use case where it won't work? I mean, can you see breaking your code for a use case?
So, okay, let's go through this maybe function by function. For the put, for each, as long as the length of self.cache is less than the max capacity, we add it to our cache. Otherwise, we
Okay, so let's say at line number 12, I change this to say this.
Yeah. So then we would enter this condition, this else.
Why?
Or rather, we would enter this because the length is 1 so far.
Yeah.
And then
what would happen if you try and put the same key value again in the dictionary?
Right. It wouldn't update the least. It wouldn't update the most recently used. So
you said it will, or it would, or it wouldn't?
It would not update the most recently used. So to explain, if we had a 1-1 and hypothetically we had a 3-3 in there, and we put in another 1-1, then this should actually move this up to the front, but it doesn't do that right now, I think.
That's correct. That's true. If you increase the capacity, you would have done that use case. But in this case, if the capacity is just 2 and you don't have this, it's basically there is just one element in it, and your capacity is still less than the max capacity, and you would try and insert that again. So it should actually eject this and insert it back in again. So that step of ejecting after line number 32 is, I believe, it's missing.
Okay, so
what you explain is the same, is the same thing, but yeah, I'm talking in capacity of 2.
Okay.
Yeah.
So just to repeat what you said, you're sort of saying that if you try to enter an existing key, then you should eject this and then add it again, right?
Right.
Okay, that makes sense.
Yeah.
I think in well, my thinking is if you already have the key, then I think this would just update the value to whatever you try to put in, and it wouldn't increase the length of the cache. Right?
It would update the value and it will not change the length of the cache. Okay, let's go by the example. Let's go by the example that you were talking about when you were breaking the use case, which is so let's say if the capacity is 3, and let's go that we had 2 here and 2 here. So you had 1 and 1 inserted, and after that you will have 2 and 2 inserted. When you do line number 13, you would get the value of 1. It will remove it and put it after on line 22. Now when you get 3 and 3, you would insert that, right? Let's say I add one another line over here as let's say we do so let's say we do this, and instead of 3-3 I say 1-1.
I see. So you're saying this does not move to the front like it should.
Correct, because you still have when you're trying to put in 1-1, you have actually, well, in this case you would do is it would remove the first element because it is over the capacity, and then it is going to insert 1-1.
Right, which is a problem.
Right. So now you have duplicates
Mhm.
over here.
Yeah. So we need to add another conditional if key in self.cache. Read self.cache at key, and then you can add it to the cache.
Right. And that is for the case when it is within the capacity.
Right.
And if it is, let's see, if it hits the capacity, in that case, you still retrieve the first key and delete the first key and then put it back again, which you will still get, then you will still have the duplicates if you, so what you're doing in the if condition should also be done in the else condition, right?
So if we had, yeah.
So with, let's go one time more. 11 and line number 12, you have 1 and 2. And at line number 13, you would retrieve 1 and put
this
it.
wouldn't be
Yeah.
here, right? Right.
Yes, right. So at line number 13, you would get 1 and put it back again in the top, right? Which would mean interchange line 22 and 23.
Right.
Right. Now on line 14, you would put 3 back, 3 in. So because you still have capacity, so you will put 3. Right?
Yeah.
Now come to line 15, you have to put 1 and 1. Now,
right.
Can you put 1 and 1? Because you still, now you have in the else condition, else block.
Right.
So going by the code, you will retrieve 2, 2 and insert a duplicate.
So we would need to do if key in self.cache, wait, self.cache at key. And so we would delete this 1, 1, and then also delete well, actually, I think this would come after. So we would delete the least recently used. We would also delete this 1, 1, and then we would put it at the front.
But why did you delete 2, 2 then? So 2, 2 is now missing.
So it used to be 1, 1, 2, 2,
3, 3.
Right, 3, 3.
Yeah.
I see.
So what should have been the output? The actual, at the end of this step, your output should be 1, 1.
3, 3, 1. Well, it should be 2, 2, 3, 3, 1, 1, right?
Right, yeah.
So you should only delete the least recently used. So we're trying to put 1, 1 back in. If it's already in there, then just delete it and then do self.cache key equals value and then just return. Maybe we can have an else statement. So if the key is not in the cache, then delete the first one. And then add the key, add the value at that key.
So can we go through the use case one more time with the code change that you made?
Right.
Yeah.
So in the beginning, self.cache is empty. And we add 1, 1. And we add 2, 2. And then we change these. And now we try to put in 3, 3. So when you put in 1, 1 again, you see that the key is already in the self.cache. So we remove.
But you won't come into the if condition because you have already hitting a capacity of 3. So now when you try to put 1, 1, you won't come to line 45 because you have the cache is no more less than the max capacity. Right? We changed the max capacity over here to 3.
Right.
So if the max capacity is now 3, you won't come here anymore, right? You will go into the else block. Right? What is the capacity right now with the current state of the self cache?
It's 3. So we will go into this else.
Yes. Now when I try to put 1, 1, what happens?
We see that the key is in the self.cache and we delete it.
Right.
And then we add it back, I think.
Right.
Yeah, I think this is a little bit messy, but maybe I wonder if there's a cleaner way to write this.
I mean, sure. I think this does the job. But yeah, you can clean it up by if you reverse the conditions if and else. If you always think that when you try to put a key and value in the dictionary, if you always try and check for its existence and then delete and add it back again, that takes care of the first thing. And then you can look at the capacity part. So, and then there are a few common code lines that can be taken out and separated, but sure. Okay, good. Yeah, this should work. Good job.